In this video, we're going to look at rational equations. And anytime you're looking at a rational equation, that is something that contains a variable in the denominator, you want to write the restricted values first, and then you want to worry about solving the rational equation. And by restricted values, we just mean values that x could take on that would cause a violation in the domain. So remember, there are two things that we want to worry about when we're talking about restricted values, up until this point in this class at least, and that is zeros in the denominator or negative numbers under a square root or under a radical. And so in this particular problem we have denominators, and so we can immediately figure out what the restricted values are by thinking we don't want the denominator equal 0. So we're going to say x plus 4 does not equal 0, and then we're going to solve for the restricted value by subtracting 4 from both sides. X does not equal negative 4. So our restricted value would be negative 4. And the reason this is important is if we get down to the very end and the only possible value that we get when we solve is x equals negative 4, then we can come back and we can say, well, x can't equal negative 4. So potentially this would be a situation where there's no solution. So you always want to do this to start out with, just in case so you can double check. So now let's talk about solving this rational equation. Again, equation because we have an equal sign, rational because we have fractions, and particularly with variables in the denominator. Now we've already solved problems that contain denominators, but up until this point we haven't solved any problems where we have a polynomial or variables in the denominator. But we're going to treat it the exact same way as other equations that we solved where we had just numbers in the denominator. We're going to find the least common denominator, or the least common multiple of our denominators, and we're going to multiply that by both sides of the equation. So in this case, really we only have one unique denominator, and that is x plus 4. Technically, you could write the 7 as 7 over 1, but 1 times x plus 4 is just x plus 4. And so the thing that we're going to multiply by all of our terms is x plus 4. So let's go ahead and make note of that. Multiply by x plus 4. Let's multiply the 7 by x plus 4, and we're going to multiply the negative 4 by x plus 4. Now again, our previous strategy was to multiply by the least common multiple of the denominators so the denominators cancel out. And the same thing's going to happen in this case. We have 3 over x plus 4 multiplied by x plus 4, so the same thing is in the top and the bottom, so they cancel out, leaving us with 3. Now our second term, we have 7 multiplied by x plus 4. We didn't technically have a denominator, so nothing canceled out. And the same thing will happen in our third term that happened in the first. We have an x plus 4 in top and bottom, so it's just going to cancel out, leaving us with negative 4. And so again, after using our little trick of multiplying by the least common denominator, we have something that's a nice linear equation with no denominators. So let's go ahead and distribute the negative 7 and solve. So we'll bring down our 3. Negative 7 times x, negative 7x. Negative 7 times 4 is negative 28 equals negative 4. So what I'm going to do is I'm going to go ahead and combine the numbers on the left-hand side. 3 minus 28 is going to give us negative 25. And we can bring down the negative 7x. And bring down the negative 4. So now I'm going to add 25 to both sides in an effort to isolate the term with our variables. And that's going to leave us with negative 7x on the left-hand side. Negative 4 plus 25 is going to be 21. Now we divide both sides by negative 7 to get the variable completely by itself. Of course, the negative 7's cancel, leaving us with x on the left-hand side. 21 divided by negative 7 is going to leave us with negative 3. So our potential solution is x equals negative 3. So now at this point of the problem, you want to go back and you want to compare that to the restricted value. If we had gotten the number x equals negative 4, then that could not be the solution because it's a restricted value. So we would have had to have said there's no solution. But in this case, since negative 3 doesn't match any of our restricted values, then negative 3 is okay for the solution, and that is the answer to this problem.